Welcome to MCR day 24. So what we're going to start with today is logic basics. So really talking about arguments, truth tables, things like that, and just getting into some logic. So I'm going to start with just the idea of what a statement is. So a statement is some sentence that can objectively be determined to be true or false. That's a statement. So for example, summer starts in June. We could say is true objectively because it does. You could say winter starts in May, and we could say false, but that's a statement. Things like opinions, questions, cheers may not be a statement. So what we're going to look at here is, again, they have to be true or false, but not both. So I hope it snows today. That is not a statement because you're just kind of wishful thinking. It's not that we can really say, oh, it's true or false. So that one is not a statement. If we were to say Barack Obama is the first Asian president of the US, that is a statement because we could look it up and see, is it true or false? Is there life on another planet? Is a question, not a statement. We can't deem it true or false. So it's not a statement. All mountains are snow-capped, though, is a statement. Whether it's true or false, we can definitely see, are all mountains snow-capped or not? So that's the idea of a statement. It's a sentence that can be judged to be true or false. So then when I mentioned all mountains are snow-capped, that word all is a quantifier. So what quantifiers do is they give you a quantity. So the quantity might be some, it could be all, it could be none, it could be a few, but it indicates some type of quantity. And we've got two main types of quantities. You have universal ones like all or none, which include or exclude everything. And then you have existential ones like some or a few, which just show the existence of something. So for example, some dogs are retrievers is an existential statement, and it's a quantified statement. We can find a dog, we can find 3 dogs. There are some dogs are retrievers. So that's a quantified statement. So as you go through problems 5 through 8, you want to figure out, are they quantified statements or not? So my car is red is a statement, but it's not quantified. It doesn't have some number attached. This sentence is false. It's a statement. All planets are habitable. That's now a quantified statement. And then on this particular one, this one was not a statement at all. It was just an exclamation, go Lions. Same here. That tasted great is not even a statement. Whoa, Nelly is not a statement. Misery loves company is not really a statement. So we're left with Disney World is in Alabama. That is a statement. We could find it true or false. Or some dogs are not beagles is a quantified statement. So that's our quantified one. With question 7, you want to read through it. You're looking for the some, the all, the none, a few. Some dogs do not go to heaven. Same for question 8. No flowers smell nice. So those are examples of quantified statements. So then continuing on, what a negation is it indicates the opposite truth value of a statement. So if your statement was P, then not P. If this was true, this is false. The negation is this tilde symbol, which I have right here, and it gives you the not. So if the statement was the semester ends in December, the negation was the statement does not end in December. So you're changing the truth value. You're adding the not, you're negating it. Now, just a note, if you have the all or the none for your quantifiers, and then you have some, a few, at least one for a quantifier, something like those, they negate each other. So it's very easy to say all and none negate each other, but you don't have to work that hard. If you say all pigeons fly, in order to negate you, I just have to find a pigeon that doesn't fly. I don't have to have no pigeons fly. So when you negate them, some is actually the opposite of all. So the negation of all birds are red is just some birds are not red. We don't have to go all the way through and say no birds are red. We can just say some are not red. We just need one or two. Okay. So we want to go through here and select the negation. Some jokes are offensive. So I'm looking for an all or a none that could do this. So I could say all jokes are not offensive, or I could say it the other way, no jokes are offensive. Both of those are correct. So some jokes are offensive means I either need to all or nothing it. Either all are not offensive or none are offensive. They're saying the same thing. And then this one, Jim went to the store and Sally did not go out. So in order to negate this, I just need to have one of these not happen. And it doesn't have to be an and. I can change it to an or. So it's going to be one of these or statements. I don't need both. So now I just need to find one where either Jim did not go to the store or Sally did go out. So I only need to negate one of them. So I don't need both. So I either need Sally did go out or Jim did not go to the store. So in that case, it's this one. Jim did not go to the store or Sally did go out. So for question 11, all movies are too long. So I don't have to jump to no movies are too long or all movies are not too long. I can just find some movies. I can find at least a movie that's not too long. I don't have to go for the all or none. Okay, for the next part of this, we're going to talk about symbolic form. So a lot of times statements are going to be represented by lowercase letters. So usually it's a P, a Q, an R, an S if you had 4 of them. But these are just going to be basic statements. Like this could be Oreos are brown. And this could be castles are cold, just statements. And then we can do different symbols to connect them together and or if then. So previously, this was your intersection and it was just what they had in common. Now it's an and because you have to be in both. So still the same as an intersection, but we're going to put that point there. So P and Q is that symbol similar to your intersection. Your union, you could be in one or both or the other. So we make that into an or because you only need to be in one or you could be in the other or you could be in both, P or Q. What a conditional says is if I promise P, then Q will happen. So you write it as P goes to Q. If you clean your room, then we will go get ice cream. Now with that, we could go get ice cream whether you clean your room or not. It's just if you clean your room, I'll give you ice cream. But with a biconditional, if and only and only if you clean your room, then we'll go get ice cream. We'll go get ice cream if and only if you clean your room. So we're not going to go if you don't clean your room. So that's the biconditional or the two-way. So the conditional only goes one way, the biconditional goes both. And then I've got them explained more down here. So we're going to take 2 simple sentences. The sun is shining, the weather is warm. So if we want to combine them with this and conjunction, we use that caret and we put and. So the sun is shining and the weather is warm. That's a conjunction. So then the next one is our disjunction or our or. So the sun is shining or the weather is warm. Then I have our conditional, which is if the sun is shining, then the weather is warm. So P goes to Q. If P, then Q. And then the biconditional says that the sun is shining if and only if the weather is warm. So it's the double arrow. So you definitely want to know these symbols and kind of have a good idea for what they stand for. Okay. So on the next one, just a refresher, this is and, this is or, if then, this is if and only if, and this is you're not. So what we want to do is down here for the following statements, we want to write each compound statement in symbolic form. So the fire is in the fireplace, the house is cold. So there is a fire in the fireplace is P. If and only if is the biconditional, and then not cold is not Q. So here's my biconditional, if and only if. Here's my not Q. And then over here, I had my P statement. So breaking that down so we can see it. Okay, pause the video and try a few of these. Okay, so looking at a couple of these, there is a fire in the fireplace, or the house is not cold. Very similar to above. Going down here, there's no fire in the fireplace, and the house is cold. Or if I switch here, if there is a fire in the fireplace, then the house is not cold. E was, let's see, there's a fire in the fireplace and the house is not cold. All these start to look alike. If and only if, this one was not P, if and only if Q. And then grabbing the few I didn't do, D was Q, goes to not P, and G, nope, I didn't do F, was not P or Q. And that should be all of them. So check your work, see how you did. Then if we go down here, you start to get into some of these that are compound. So with compound, sometimes we also have to put parentheses. So for example, the water is warm or the sun is shining. Then there's a comma and we don't go swimming. So the water is warm or the sun is shining and we don't go swimming. So that's where your parentheses would go. If the sun is shining, comma, then the water is warm if and only if we go swimming. So that one was Q goes to P by conditional R. So in English, we wouldn't have these parentheses, but when we put them in our math, we are going to put those parentheses. This is the promise. That's what we're going to do, but it's also a biconditional. So for A, not P, goes to Q or R, just to check a few of those. All right, the rest are on the answer key. So finish up, check your work, see how you did. Then we are going to get into converse, inverse, and contrapositive statements. So when you take your original statement, and you say P goes to Q, that's your original statement. And then we can do something called a converse. So a converse, kind of think of confuse, where you flip them. So you just flip them around. Sorry about that. So the converse would be Q goes to P. The inverse, kind of think of a mathematical way where you're negating. And then the contrapositive is the longest one to write. So you do both. You flip and you negate the original statement. So you do want to know those. So here's your original statement. Here's your converse, your inverse, and your contrapositive. So if we have the conditional, if it snows, then John Tyler cancels classes. So P is it snows. Q is John Tyler cancels classes. Hypothesis, conclusion. So that's the original statement. If it snows, John Tyler cancels classes. That's true. We're going to assume it's true. The converse is to flip it. If John Tyler cancels classes, then it snows. Well, that's not necessarily true. We've had to cancel for hurricanes, tornadoes, pandemics, power outages. So that's just not true. Then the inverse is where you just negate it. If it doesn't snow, then John Tyler doesn't cancel classes. Well, those were kind of saying the same thing. So that's still false. And then the contrapositive is where you flip and negate. So if John Tyler does not cancel classes, then it didn't snow. Well, if it snows, they cancel. So if they didn't cancel, it didn't snow. So that one would be true. So again, you want to make sure that you know these: the statement, the converse, the inverse, and the contrapositive. So for some practice problems, you want to write these out. So you might want to pause the video and try these. So if you go to office hours, you pass the test. So the converse is flipping it. Q goes to P. So if you pass the test, then you went to office hours. Well, hold on. If you go to office hours, you'll pass the test, but there's other reasons you might pass the test. So this is not true. The inverse is negating it. If you don't go to office hours, so if you don't go to office hours, then you won't pass the test. Also not true. You know, there could be other reasons you pass the test. Now the contrapositive is flip and negate. If you did not pass the test, then you did not go to office hours. Now that one is true, because if you go to office hours, you pass the test. So if you didn't pass the test, lots of reasons could be at stake, but one of them is because you didn't go to office hours. If you go to office hours, you pass the test. Okay, then I'm going to go down to 16. It says all flowers are beautiful. So we need to write that as a conditional. If it is a flower, then it is beautiful. Okay. And then we can go through and we can flip them. So I have the answer key posted. So go through those. Then finishing up. So that's your part 1 of day 24 assignment. This is part 2. So what truth tables are is they are mathematical tables that tell us the truth values for all possibilities for different statements. So to start, if I have 2 statements, P and Q, the possibilities are true, 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 false, false, true, and false, false. I'm not figuring those out. Those are just the possibilities. So then if I do P and Q, and means I have to have both for it to be true. So here where I have true, true, I also have a true. Every other time I have at least one false. So therefore overall, the and is false. So again, for this one, you'll notice these are the same. You don't memorize these. It's true, true, false, false, true, false, false. Those just are what they are. So then for an or, you only need to have one be true for the whole thing to be true. It's only false when both are false. So as long as you have one true, then the whole statement is true. If you have 2 falses, then it's false. And then for number 3, again, these are just the ways you can put P and Q together. You don't memorize these, they're just given. All right, what we have now is we have the conditional. So a little bit with the conditional. Think of P as the promise. Okay. So when do you break the promise? That's when you'll get a false. Any other time, you don't get a false. So I'm going to jump to the falses first. This part was never fulfilled. If you clean your room, then I'll get you ice cream. You didn't clean your room. Therefore, I never broke the promise. So these have to stay true. Now, if you cleaned your room, I gave you ice cream. That was true. The only time I break the promise is when you did do it and I didn't do what I said I would do, in which case it's a broken promise, false. So kind of keep that in mind, that it's when did you break the promise? Well, you can only break a promise if the first part was fulfilled. You can't break it otherwise. Okay. So then our last item, this is in your day 24 part 2 assignment. We're going to look at this statement. If it's sunny, I wear sunglasses. And we're going to again look at the conditional statement. So the conditional would be the options are just true, true, false, false. Same for these. Same idea as we just wrote above. We just got to look at where I invalidated the statement. So it was sunny. I wore my sunglasses. True. It was sunny. I didn't wear my sunglasses. Here's now where I actually invalidated the statement. And so it's false. And then down here, it's not sunny. I wore my sunglasses. That's true because it didn't invalidate it. This one validated it, but this one didn't invalidate it. Whereas this one did. And then it's not sunny and I didn't wear them. Well, if it's not sunny, we don't care. The idea was if it's sunny, you're going to wear sunglasses. So if it's not, it doesn't matter what happens. You didn't invalidate the statement. So that's just that one more time mentioned. So again, the summary for the conditional, the front has to be true for the back to be false. That's the only way you can get false. Otherwise, it's always true. So if you didn't do the promise, you know, if you didn't do P, there's no way to say it's false. So here's just a couple more to try. Go ahead and try them out. This is your symbol for and. This is your symbol for or. This is your symbol for not. And then you'll see we give you the first two columns in each. Those are just given. So what not P does? Not P negates P, meaning it flips all of its truth values. So this one goes to false, false, true, true. Then this one says, well, now I want not P and Q. So I want you to now and these two columns together. I want to see what happens here. So with an and, both have to be true. So that's only right here. Otherwise, you have a false, and a false. So we only have the one spot where you're going to be true when the other two are true. And then here, not P negates P again. So it'll be false, false, true, true. And then this one now says or. So for or, you only need one. True to be true. So this one is doing these two columns. Okay, so that's true. That's false. That's true. That's true. And we're in good shape. Okay, and then I'm going to jump to question 7 and kind of do the whole thing. So not P negates P. So false, false, true, true. Not Q is going to negate my Q. False, true, false, true. And then this one is saying do P or not Q. So I've really got to start to watch which column I'm looking at right here. And that's an or. So I only need one. So true, false is true. True, false, false. And then I have a true there. Sounds good. All right, then this one says, well, now I want you to do not P with this thing and do an and. So I'm going to look for the only time I have two truths in those columns, and every other time it's going to be false. So I only have the two truths there. So false, 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 true. So you have a part 1 and a part 2 for these assignments, and you turn them in on Canvas and have a very wonderful day.